Hello, everyone. Thank you for joining us for the next session of our Model Mondays series. My name is Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters and guests to answer live. Our session is recorded. It will be available to view on demand within 24 hours right here on the Reactor channel. With that, I'd love to turn it over to our host for today. Carlota, thanks so much for joining.
Hi, hello everyone, welcome. Good morning, good afternoon, good evening, wherever you are in the world. I'm joining from Italy, and huge thanks, Anna, for the kind introduction. So I'm Carlotta Castelluccio. I'm an advocate in the DevRel team in Microsoft, and I'll be your host for this episode. So welcome to this new episode of Model Mondays. And if it's the first time for you joining this series, Model Mondays is a series running on Microsoft Reactor every other Monday, designed with the ambition of helping AI engineers and developers choose the right models for their AI apps and agents, which becomes harder and harder as there are such a huge amount of new models releasing every week. We also host AMAs on Fridays on the Microsoft Foundry Discord community as follow-up, but I'll give you more hints, more details about this later. For today, we have a quite packed agenda and very interesting agenda. We'll start with a partner spotlight section featuring Anthropic and some, latest and greatest from Anthropic models and agents, and the customer story using Anthropic models in a real-world project. Then we'll see some news highlights of the week in Microsoft Foundry and hacking phase. And finally, we'll get to the tech spotlight section where we'll see some hands-on demos with the Microsoft Foundry Agent Service. So I'm really excited for this. Let's get started. And to get things rolling, I'm pleased to welcome on stage my co-host, Sharmila, that you probably know from previous episodes, product manager at Microsoft. Hi, Sharmila.
Hi, Carlota. I'm super excited to be joining again on Model Mondays. And as you said, we have quite a packed agenda with interesting first-time participants like Anthropic and Carolyn from Anthropic. And we have an interesting customer lined up as well. It's going to be Replit, who's also going to talk about how they're using Anthropic models in Foundry. And then, of course, we have our internal guest, Bala, also joining us. So I'm pretty excited with this, what we have lined up today.
Wonderful. So I would say let's get Karen on stage as well. So we get started. Hi, Caroline. How are you doing?
Hello, everyone. Great to see you.
Do you want to quickly introduce your role in Anthropic?
Absolutely, yes. So Caroline Matthews, I am an applied AI architect. So I work with our partners on how they can incorporate Anthropic into their solutions and use all of the great offerings that we have.
Awesome. So the floor is yours, Caroline. Walk us through the latest and greatest from Anthropic.
That sounds great. Yeah. So today, that's exactly what I thought we'd cover. Is we've had some exciting announcements with some new models that have come out and a lot of new features. So I've got a few demonstrations I have set up as well, so we can take a look at how it actually works in practice. Did you have the slides?
Yes. Here we are.
All right. Thank you. So just before I jump into all the new models, I wanted to hit on this for a moment. Important to note, Anthropic, we're really focused on the enterprise and have built that way from the ground up. So this is the lowest hallucination rates in the industry. We have models that are very trustworthy, seamless integration into the tools that you're already using, and of course, running natively on Microsoft Azure. And so on the next slide, we'll jump into some of the newest models, Claude Opus 4.6. If you can go to the next slide as well. So this model was released a couple weeks ago. This is really our flagship, most intelligent, most capable model. So it's really known for being able to work through complex multi-step problems independently. So it can also work much longer than previous models. And that's important when we think about these agentic capabilities, is being able to work over very long running processes. And one of the very exciting new features is the million token context window input, as well as 128,000 output tokens. So this means it can really work on large code bases, enterprise documents, massive amounts of information. So again, making it much more capable and just really a frontier model with a ton of capabilities. If you can go to the next slide. I'll just talk very specifically about what's new with Opus 4.6 compared to Opus 4.5 for anyone that was working with it. One of the key concepts I mentioned is that it's not just doing the task better, it's really partnering in a different way. So much more like a genuine engineering partner, not just writing code, but planning and reviewing and debugging, and it'll check its own work before it says it's done. Another key thing is that improved situational awareness. And this is something I think everyone's probably happened at some point is, we'll get into a really hard question and it's like it's just beating its head against the wall, trying the same thing over and over again. This is where Opus 4.6 is much better at being able to regroup and essentially track and change situationally on something that's occurring in the work stream. And overall, just better at multitasking and agent orchestration. So handling concurrent work streams, managing really complex tool call sequences. So this is really a great foundation for any types of use cases. And if you go to the next one, perfect. And speaking of use cases, I just mentioned the coding one and enterprise agents, but two other that really stood out in testing with this model, cybersecurity and finance. And so what we mean by this is that with the cybersecurity, it really can extend what a human analyst might be doing. So analyzing threat patterns, identifying vulnerabilities, really being able to reason through an attack surface. And then with finance, as I mentioned, being able to ingest those massive documents, but also to really be able to synthesize and get strong insights with that finance background or capabilities that the model is displaying as well. Thank you. All right, now we'll move on to our very latest model on the next slide. So Claude Sonnet 4.6, and you can click to that and we'll get to the meat of the matter. So Claude Sonnet 4.6, this is our very latest. This was just released last week. And there has always been a trade-off in AI in terms of the frontier intelligence, but you also have the economics of what's the most cost-efficient way to be able to do this. And what Sonnet brings us is one of the smartest models in the world, but it's at scale. And so it kind of gives you that great sweet spot of it can approach that Opus 4.6 levels of intelligence, but it's at a Sonnet pricing. So for your high volume workloads, thousands of API calls per day, this is a great one for you. And it's not a compromise. It is frontier intelligence. It just can run at scale. So it's really designed to do more of that back and forth development. So being able to iterate, but with fewer rounds of iteration in order to be able to accomplish the tasks. And also with things like office work and production ready documents, spreadsheets, presentations, being able to produce those sorts of things as well. And so the early customer feedback has been really encouraging. People are telling us that it is Opus level quality, particularly with coding and reasoning and computer use, but it is at that meaningfully lower cost. And we'll click to the next one, please. All right, I'll do this kind of quickly. I want to jump into our demos, but so what's improved? Again, faster coding. There's fewer of those iteration cycles that are required. That same, what I just spoke about with the situational awareness. So being able to regroup and change courses midstream. And it's also very strong with orchestrating the complex workflows, as well as being able to extract insights from documents, turning unstructured information into structured understanding. And the next slide. We'll do this one quickly because it is a bit of an eye test, but the benchmark table, the key things to point out, all of these models do really well. The one that's right in the middle with all of the red blocks, that is our Opus 4.6. One thing that's kind of cool, though, is you'll see Sonnet 4.6. It also does extremely well, and in some cases even a little bit better potentially, especially with finance tasks, as well as being able to do some of the computer usage types of things as well. And then one more slide. This is kind of our best take on a cheat sheet for which model to use when. So you'll notice Sonnet 4.6 is the first one on the slide here, and that's because that's really your workhorse. This is one you should start with. It's an excellent model. You can deploy it and run amazingly complex processes and very agentic orchestration types of tasks. But then we have our Opus. Think of that as your specialist. So that's when you get into really hard, complex reasoning, long documents, long horizon, agentic tasks, or any of those real true frontier coding challenges. And as I mentioned, cybersecurity analysis, things like that. Anytime where the cost of getting it wrong is high, Opus 4.6 is probably worth that investment. And so that's really your specialist that you bring in for those use cases. But we also have Haiku. And last but not least at all, it is that third tier. So this is your latency sensitive applications. So simple things, kind of high frequency tasks, cost optimized is what you get with Haiku. And so it's really going to be great at executing tasks that might be planned by Opus or Sonnet, for example. So really, most organizations would use all three and within the same workflows even. So an orchestrator could route tasks to the right model. So you can get those Opus quality outcomes when you need it, and then Haiku efficiency when that is what is suited. Thank you. All right, next up is our new capabilities. So we're going to jump into this. I'm going to do just a quick intro, and then we'll get into some demonstrations of this. You can go to the next one. So the three main things that I'll talk about today: adaptive thinking, context compaction, and then I've mentioned already 1 million token context. That is for your inputs. If you go to the next one, we'll talk a minute about adaptive thinking. So with Claude Opus 4.6 and Sonnet 4.6, we're moving away from the extended thinking model, where developers, you had to manually set a token budget for how much reasoning, and we've moved to what's called adaptive thinking. And so this is where Claude can dynamically decide whether to much reasoning and whether or not to apply reasoning based on how complex the request is. And so instead of a fixed token budget, now you have an effort. So there's low, medium, high, or max. And we'll jump into this. I'll show you more about this. But this is, again, where it can really now think between the tool calls, not just when it's responding. So it gives us a bit more there as well. And it really can work in terms of cost and latency. So not every query requires that deep reasoning. So let's use it when we need to, and otherwise we won't. And just a quick note there, the budget tokens approach, it is deprecated. It still functions, though. All of that is still work. So there's nothing that would be breaking, but it is just kind of a signal that this is the direction for the future. So this is a good one to start moving towards. And then the next slide, I'll talk about context compaction. This is actually a pretty exciting one because it just takes something, a very important concept and automates it for you. And so when the conversation begins to approach your token threshold, now the API will summarize that older history and replace it with a summary so it can keep going. So it's a way to very quickly be able to maintain a conversation. And what we're seeing is as much as like 58% token savings in some of our agentic workflow tests and benchmarks that we've been looking at. And this is available as well. And so this is when you're building an agent that needs to be able to do really sustained, long-running work. This is really going to be a game changer. And we jump into our first demo now and take a look at adaptive thinking and context compaction.
All right, let's dive in. So to get started, I'm going to show you some of the new features using Claude Opus 4.6. I have already deployed my model using Azure AI Foundry. I have configured and set up my Anthropic API key on Azure. And what we're going to do is use this Anthropic Foundry client, which is part of the Anthropic SDK, and just do a quick test with a question to introduce, and you'll see that we got our response. So we're all connected. So first thing we're going to look at is adaptive thinking. And for adaptive thinking, there's a couple key parameters that you want to remember. So I'll just kick this one off to get us started. But the first one is we have this thinking parameter that you're going to set the type to be adaptive. And then you also have this concept of the effort level. Now with effort, your configurations are high, medium, low, and you have max. And the way this works is it defaults to high. We assume most things will need some thinking. But if you set it a bit lower, like lower medium, Claude will determine if it needs to think or not. And in this case, for this very simple question of what's the difference between a list and a tuple, it did not need to think. And we know this because we did not receive a thinking block in the response. And so what we do receive, obviously, is the answer, and you can see a pretty quick response. But let's go into one of the harder ones. That's what's going to really show this off. So in this case, we have a math problem that is a kind of complex. There's a few steps involved. There's going to be some interim calculations. So definitely a good point to use some reasoning. And what I did this time is I just set the thinking parameter. So I've set that to adaptive, but I didn't set the effort because, as I mentioned, it's going to default to high. So this gives us a chance just to see it kind of working in its natural element. And so we'll check out the responses that we got. And you'll see in this case, we did get a thinking block. And this is great because this actually lets you see exactly what the internal reasoning. I'm just printed out the first few characters of it, but you can go through and see exactly what it's done. And then we get our answer, which is a pretty specific answer here. And that looks good. You have to trust me, but that is the correct answer. And so just to make this a little more real is we're going to show using this. I ran this ahead of time, so it takes a little bit, but I ran the same hard math problem using all of the different levels so we can see what happens. And so the different effort levels do and the output of the results is pretty different. So first one is low. And what we see here is we get pretty close to the answers, but they're significantly rounded off to thousands, actually. So this is not really a great answer. Even it realizes it should probably take a look at that again. Now, for the medium effort, this one is an interesting one because we get actually a great answer, a very precise answer. And it took a little bit longer and the more tokens to do it, but we got a better answer. Now, when we go to high, which is what we did in the first round, you'll see we got the same answers that we get for medium, but it took longer and it took quite a few more tokens, almost double the number of tokens. And when we look at max, it's even more. So higher, longer time to process, as well as much higher token count. But we do get a great answer. It is a little bit less precise, which is interesting. And this is the thing with max is it could be that this is considered a better answer. But generally max effort is going to be for your very complex problems where you need that level of effort for the token cost and the time and the latency that you're going to see from that. But that doesn't mean you should always use it. In this case, medium does an excellent job, as you can see. So this is, again, just the ways that you can optimize for this new parameter of adaptive thinking. And next, we're going to look at compaction or infinite conversations. And the way this works is as we hit our context window limit, in this case, I'm going to demonstrate using the 200,000 limit window just to make it a little bit easier for us. And then we will see that when it hits, I think it's about 167,000, it's going to automatically compact. And the way we're going to test this is A, we want to see that it does that, but B, we're also going to hide a couple little Easter eggs for it to remember so we can check how well it handles once it's compacted. Did the information come through as it needed? And so to do this, we're going to download an open source version of Pride and Prejudice, which has about 728,000 characters in it. And the first thing I'm going to do is I'm going to insert a password in the middle. So this compacted but not forgotten is my secret password. I'm inserting it basically halfway through the whole novel. So about 364,000 characters in, I've inserted this. And what we're going to do next is start our conversation. So this first conversation we're going to run, we're just going to seed it with my favorite color, cerulean blue. So we're going to see this at the very beginning of the conversation. And just to show the syntax, this is a beta feature right now. And these may change, so from the time that you're seeing this recording. But right now, this is the way that you configure this. So it will do that automatic compaction for you. We're going to run this conversation. We're not actually seeing any compaction yet. This is just to seed things. We have this little small talk, little bit of tokens. We have that in there. So that's now being maintained as part of our messages. All right, so now in our second turn of the conversation, we are going to append the entire novel, including the little secret that we stuck in the middle of it, to our conversation. And this is what's going to put us over that 167,000-ish limit for this particular version of the model that uses the 200,000 context window. And so what we're going to see happen is we started out with about, 183,000 tokens, and we got down to 201 tokens after it compacted. All of that happened automatically. You see about 10 seconds is what it took to run. But we got down to a much smaller number, and it said that it has completed reading the text. So now the big test is, will it remember those things after it made such a significant decrease in the amount of tokens that were used? Will it still be able to recall those things that we told it? So this is our last turn of the conversation. We're just going to append the question of what is my favorite color and what was the secret password hidden in the novel. And this is where we're going to see, again, we still have the compaction set up, but at this point we don't need to compact because we are just sending the tokens that it had compacted in the last round, along with the question that we're asking here, which is to get our results. And so input was about 297 tokens. And here's our answers. Yes, it did find the favorite color, and it did find our secret password embedded in the text. It actually told us exactly where. Now, so kind of a fun thing just to bring this all home, but the compaction in action, this is where we can see the significant reduction that we had in that second turn of the conversation when we fed the entire novel into it along with the first pieces. And then you can see at the end a very small number, so 297 total, and we were able to get our answer. So anyway, great way to see adaptive thinking and compaction in action.
Great. Thank you. You know, as I was watching that, that was a pretty easy one I gave it. So that massive amount of compaction, that, like I mentioned, 58% is the benchmark. But that was it's a fun way, again, just to show, because that novel is a pretty simple thing for it to actually keep track of as it goes through that process. But so one other thing I wanted to chat about today, if you can go to the next one, is agent teams. And this is a very exciting new feature. So this is it's in research preview, but it is very exciting, as I mentioned. So the idea is pretty simple, but it's very powerful. So this is being able to spin up multiple Claude agents that can communicate with each other. They can coordinate, they can divide and conquer. So it really gives you a way to do very smart parallelized work, as they can talk to each other and they can steer individual agents. So instead of just having a single agent that's going to work through a long task, you could have a team that's tackling different parts simultaneously. So it's a great way to really extend the features of what you can do. And I have one more demonstration to show about agent teams that is just a little fun way to see them in action.
Demonstrate Claude Code and some of the new capabilities in it. And what we're looking at is the VS Code extension for Claude Code, and we're going to look at using agent teams. Now, to set this up, we're going to do something kind of fun. We're going to build a Space Defender game as a single HTML file. Now, the hint I'm going to give is to use 3 specialized teammates. That's not entirely required, but it is kind of a nice way just to make sure it happens for this demonstration purpose. So let me go ahead and copy paste that into Claude. And away we go. And so just to give a little background on what's going to happen here is we will have our main agent orchestrator, and that agent is going to spin up this team of agents that's going to do each of those 3 tasks, which is the game engine, the visuals and the UI, and then we're going to have an audio engineer as well. And so each of those agents will then, in parallel, go through the process of building the pieces that are critical for their part of the task. And then we will see it all be put back together as we continue letting it work. And now we can see each of the agents has been spun up, and they've been given their specific instructions by the orchestrator. Minutes has passed. We can see, just to begin with, that all 3 of the specialist teams are working in parallel, and we can see each of them as they complete their tasks and the outputs. And then the next piece is where the orchestrator is going to put this together. As you can see, the game engine audio is done. It's just waiting for the visuals. And as that's finished here, all of them are going to be integrated into that single HTML file that we requested. All right, our orchestrator has finished combining all of the information. I'm going to do this, yes, and just allow everything so it can go ahead and finish up. And the last piece it's going to do is some testing to verify that the game works. And then we'll take a look at it as it finishes up. Right. Now we can see it finished all of its testing and verification, and it's let us know each of the steps that the individual agents worked within the team and gave us some instructions about how to use it. And let's just take a look at what we got. Here's our Space Defender. We'll hit this, and ta-da, we have a game. And there is audio. I'm not sure if everyone could hear it, but the audio engineer did a great job, and we're able to actually play our game. So this is a bit of a silly example, but kind of fun just to see the way that the different teams can work and how good it is in organizing with very little direction from an individual engineer. You can have these teams spun up to do things in parallel. This could be used for things like writing documentation and writing test use cases at the same time that you're writing the code, bringing in security checks, looking for vulnerabilities while writing code or while looking at code that's been written. So these are all the sorts of tasks that you can use the agent teams to.
Perfect. Thank you. I cut off a little bit there, but basically that was the point, is agent teams can be used for many different types of tasks in the overall development lifecycle. And yeah, so just an exciting new research preview, but something to please start experimenting with and see what you can build.
Thank you, Caroline. That was very, very interesting, very impressive demos. Thank you for bringing some hands-on examples. I really love the game one. And I'm looking at the chat. There are some comments about people using already these models in their own coding workflow, like in GitHub Copilot, in other IDE. So it's nice to see that people are, playing with these models already.
Yeah, and Carlotta, if you don't mind, can I ask Carolyn just one or two questions that are related to what she showed right now before
Yes.
Replit? So Carolyn, one question we got when you were showing the compacting, context compacting, how they asked, how does the LLM know what to preserve when compacting?
That's a great. Oh, sorry, go ahead.
And then the second part of the question is, you could have asked it about the characters in the novel. How does it reduce it to 200 tokens?
I'm so glad that this question came up, because that's what I really, in the demonstration, I feel like I gave it a very good, simple case. The novel itself is just a bunch of text. And so it very easily can summarize the themes of the novel, the characters, just like what you're saying there. We could have asked about that. That's a great thing, actually, I could go back and do. But so when it's just a big chunk of text, and also it's a very well-known, open source, not copyrighted piece of information, that's why it could reduce so much on those, the example that I gave. But in the real world, when you are doing tool uses and you're getting responses, you're not going to see as much of a reduction, but you will see it's very smart about stripping off the extra things that aren't necessary, the scaffolding parts of the conversations. It's really going to distill it down to here's the inputs and the outputs, the things that it needs to remember. That's really what it's trained to do, is to be able to find the most important pieces and only maintain that when it does the summary. And so that's how the reduction, and that, like I said, so in the real world, you're not going to see as much as I showed in that demo, but you should still see a significant with 58% deduction.
That's awesome. And I have one more question that's related to the agent, what you showed on the agent demo. So I'm going to ask that before we move to Replit. The question is, at face value, Claude Code agent teams and MS agent framework seem similar. Are you familiar, Carolyn, about MS agent framework? They're asking for substitute for one another, or are there specific use cases for each?
Well, I'm going to spin this a little bit, that the real thing that we're getting with the agent teams is that parallelization. That's really what is the unique there. In terms of we had sub-agents is one of the ways that we looked at it as well. And the main thing with the agent teams is their ability to communicate with each other across, so they can have a shared task list, even some of that. So I'm just spinning that question a little bit, that's really what the difference is that in any kind of an agent framework, you would be able to do sub-agents, and you essentially have one agent that spins up and work, and it reports back to the main agent. This is the different in the paradigm would be now the agents are communicating with each other in addition to back to an orchestrator. So that's kind of the way that those work.
Awesome. Thank you so much. We still have more questions. We'll come to it after we get Replit on stage. And Replit is a customer of who are using Anthropic models. They're also using other models in Foundry. But today we are going to focus on Anthropic model usage by Replit. So maybe, Carolyn, we will do another round of questions after we get to Replit and walk through their customer scenario.
Great. Thank you.
So let's bring on Scott from Replit.
Hi, thanks for having me. I'm Scott,
Hi,
Vice
Scott.
President Engineering at Replit.
Hi. Oh, sorry, there was a small lag in audio. Hi, Scott. Really excited to have you here, and we would love to have you showcase your product, like what you do and how you're using Anthropic models in Replit. So if you can get started, like give a quick overview of Replit and jump into your what you have that you want to share with us.
Yeah, the best way to show it, I think, is to do a demo. But first, I'll give a little bit of framing for folks who aren't aware what Replit does. Replit lets anybody build software with natural language. I say anybody because we're trying to really help non-engineers primarily, people who are not software engineers today. And we're helping them to build sort of production-ready best practices software. And so one of the big problems we end up solving is what we call this engineering bottleneck. So I run a large engineering team. I will tell you that I'm constantly telling people with good ideas, no, we can't do that. We just don't have enough people. Many of these ideas are actually not directly related to the product you're working on sometimes. It could just be the sales team needs a better way of managing doing their quotes. A lot of times you end up buying software and like paying too much money for it. And then even more ideas just sort of die because there's nothing out there to buy. It's maybe too narrow of an idea or it's specific to that company. And so Replit is AI-powered vibe coding, meaning you don't have to write any code. You just have to describe what you want. You don't have to be technically well-versed. Sometimes it helps if you use the right terms, but we've really set it up so that you can succeed if you don't. After you get that first version, you can keep iterating, adding features. Most software is not correct the first time you do it because there's nuance and feature requirements come in, and so you keep going. And then we can get you to deploy a production-ready, secure app with one click. So we're really building in a lot here so that you can succeed without having to go elsewhere. We will provision databases for you. We can handle your domains, TLS certifications, scaling, securely store secrets, let you collaborate in real time, and then it's all SOC 2 compliant and has RBAC and other things that'll let you work inside an enterprise. A question I get a lot is who ends up using Replit? Like I said, we're really aiming at everyone who's not in engineering, and that doesn't end up putting you in one vertical or even to one type of role. We will see product managers who are very successful users. They know how to talk about software requirements really well, so they end up being great prompters. And they're usually trying to envision some new part of their product to help speed up the software development lifecycle. If you can get to something you can touch and feel in an hour, you may have actually just saved months of debate about what to build. And so that's really powerful for them. And then you've got folks inside companies in operations roles or in sales roles. Enid, who runs our deal desk, she built a quote configurator on Replit. It's probably the most used internal tool we have. And so now we have no need to go purchase software like that. She just knows enough about how we do our sales process. She built something totally tailored for them. Under the hood, we're using, why I'm here today, we're using Microsoft and Anthropic. So we're getting the Anthropic models from Azure Foundry. When we deploy that customer application, Microsoft is really handling the tenancy. It's in the user's specific subscription and also helping us with network things like DDoS protection. So we're getting that really high-grade, secure environment. And under the covers, they're running as Azure Container Apps, which is just a really great way because if it's an internal tool, you don't have to overpay for your compute. And if it's something you launch yourself out into the world and it really takes off, it will scale up. So like I said, we're trying to bring the next billion software creators online. That would put you basically at the order of magnitude of people who can use a spreadsheet today. I think if you can use a spreadsheet today, you should be able to build an app for yourself. I think it's going to be that easy, especially because we can take care of a lot of things for you. And so if you've never tried it, you can get out there and try. It's free to try. It's at replit.com. But it's a little easier if I just show you how it works. So I'm here in my company's internal workspace. We've got some big launches coming up. So if you have a very careful eye, you may see previews of new features that I'm just dogfooding right now. But I've described a basic application here. It's not an overly long prompt, but I want to create something called MicroAnt. It'll let me model out a software system as an Azure deployment and figure out what the system architecture should be. If I click start here, we will launch into the workspace. Under the covers, we're using a number of models. Anthropic is really carrying the load here with Opus and Sonnet. We even use some Haiku. And so it's going to start writing files, and you'll see it doing its thing over here. Now, this first version of the application will come out in some number of minutes. This one will probably take between 5 and 10, because I gave a number of pretty meaningful features. But I'm just going to flip over to when I did this morning. And eventually you get something that looks like this. So here's our application. It's running. We have the ability to have multiple sessions and chats. And so I can come here and talk about a system I want to build, and then it will draw up my system diagram and give me a spec. So it suggests I should talk about an e-commerce system. And so I'm using the new Sonnet and Opus models here. And so I didn't really give it enough information, so it's going to ask me to talk a little bit more. I could force it to give me a diagram anyway. But what's kind of interesting is all the things that happened under the covers, not just the code. So we provisioned a database. We actually have two, because development and production should be separate if you're following best practices. So you can see, since my production database is non-empty, you can come here, browse. You can even interact with both versions of the database. It's because I've already published this to the internet. So I can show you in a minute, and you can see logs. You can see analytics. Those requests are all me. There's only one user so far. No one's found this yet, and you can see it's coming. It's me, 95 hits from the US. And then I can flip over to that. So we're live on the internet with this application. I didn't do this all in one prompt this morning. I did a few different prompts just to get it to something that felt a little bit nicer. And it probably took me a total of 30 to 45 minutes, which is pretty amazing. This is a really modern feeling app. You can see it's got history and persistence in the database. Here, I actually went back and forth on what describes Replit's architecture. And it came with this is an Azure version. And it's actually fairly accurate. It's not exactly how we built it, because we built it up over the years. But if I were to start from scratch, this is kind of what it would look like. So we've got AKS for the coding sandboxes. We got Azure Container Registry and Container Apps for hosting the user applications. It's using Enter ID, because I said this was meant to be sold to businesses using SAML and Skim. And then it even wrote me up a nice spec here. So I can take this to my team and explain exactly how I want it built with data flows, security. I mean, I never sort of cease to be amazed at what models can do. But it's really nice to have this all bundled in. I didn't have to think. This is live on the internet, sort of in a secure network, in the Replit organization tenant, keeping it safe and keeping it ready to scale up should I go get a bunch of users. So far, just me. And that's my demo.
Awesome. That's really great, Scott. We do have a bunch of questions. Before I start asking you the questions, we can also bring Carolyn on stage. I'm going to kind of tag team between you and Carolyn, because there are a few questions for her and for you as well. So Scott, let me start with you. There was a question around, does Replit build with pre-built vetted components, or does it generate raw code?
It's primarily generating raw code, although there are a few things that we allow it to just sort of paste some things in. Icons, for example, are convenient to pre-generate. And a few of our integrations, it makes sense to pre-generate a little bit of the glue. But it's mostly a model like Opus generating code.
Okay, awesome. And then, Carolyn, I'm going to ask you a question that came up, which was around, give me a second. Does Claude Code agent teams also use kind of spec kit kind of requirements?
So the way it works is it's called Claude.md, if you're familiar with that, but that's kind of a shared project spec. So your main agent, there's this Claude MD that it kind of describes the overall project and what types of work would be completed, as well as what the scope is. But then in addition to that, that's where as the team of agents are spun up, each one of them is going to have both that spec from the Claude, but they're also going to have the very specific things that go into their prompts. So that would be what their role is, their task dependencies. So all of that is kind of what comes together to be an engineering spec, but then each of the agents also has their specific tasks that they complete as well.
Awesome. Great. I'm going to, because we are running out of time, I'm going to ask one final question to Scott, and maybe we can address the rest of the questions offline. I know there are a bunch of questions coming in again. But Scott, one question is, can I use other LLM, local LLM, other databases, security, REST standards, React versus Angular with Replit?
So you can. We try to have well-configured defaults in there. So like we always choose Postgres as the database. But you can connect using OAuth or using an API key to other services if you like. And then the agent can use those to build out.
Awesome. And what language is the app built in? That's one final question to you, Scott.
This one's in TypeScript. So
Okay.
that's sort of our default. Again, having some defaults is really convenient for doing things well, but we would allow you can go in and say, I want Python and I want you to use Fast API or something like that. It'll still work.
Awesome. I know we are out of time. Scott and Carolyn, really appreciate you jumping in and like talking through Anthropic models. And Scott, how you're using Anthropic in Replit. There are still a bunch of questions that are coming in the comments. So feel free to, if you have the time, you can go in and type the answers to those questions. Or if you don't, that's fine. We will collect all the questions and try to answer them later as well. And Carlota, I'd like to hand it over to you before. Yeah, and thank you again, both to Carolyn and Scott.
Thank you so much for joining us, Karen, Scott. And yeah, thanks, Sharmila. So let me share my screen again. I think what we have next is some news highlights from Microsoft Foundry World and Hugging Phases. So let's get to
Carlota, one thing, maybe because we are running out of time, maybe we can skip the news highlights and keep it towards the end. And
okay. Yeah, let's do that. Yeah, let's do that. Yeah, because we have we have another guest for today. So let me pick up the right one. Here we are. Yeah, so let me welcome at this point Bala on stage, Principal PM at Core AI in Microsoft. Hi, Bala. Thanks for joining us today. We have some very nice hands-on demos from Bala around building your agent with Microsoft Foundry, and specifically with the code-first approach. So using the Foundry SDK, but I do want just to do a very brief introduction before we go to the hands-on part, which is the core of today's session.
Yeah, thank you, Carlota. So hi folks, my name is Bala Venkataraman. Sorry if I don't sound too enthusiastic. It's not that I'm not enthusiastic. I'm super excited to be here, but my throat is not cooperating with me. I'm a PM in Microsoft. Been here for like almost 18-19 years now, and I own the agents service in Microsoft AI, Microsoft Foundry. I'm pretty sure you guys are not here to learn about me, so I'll hand it over back to Carlota so she can run the demo where we're going to look at agents and what you can do with them.
Cool. Yeah, let's look at the demos.
Let's talk about Foundry agents. I'll start with concepts. Foundry agents work in a simple loop: agent, conversation, response. The agent is the blueprint, model, instruction, tools, and guardrails. The conversation manages state automatically, tracking messages and tool calls so you can get true multi-turn continuity without passing context. Each interaction produces a response where the agent reasons, invokes tools, and generates out. That output feeds right back into the conversation, powering reliable, stateful agent experience in the Azure AI Foundry. Now, what are the advantages of Foundry Agents? Foundry Agents are built on 3 big wins. The first, developer productivity, enterprise readiness, and API modernization. For developers, agents support more models. You can use Azure OpenAI models or non-OpenAI models, including Meta, Grok, DeepSeek, Anthropic, and several others. They are built around powerful built-in tools, and they're all based off of the Responses API, where new features land first. For enterprises, agents are single tenant, and if you create a standard setup, they're single tenant by default. They have strong security, clear separation of definition and execution, and options like bring your own Cosmos DB for state. And with the modern APIs, conversations handle state automatically and support both single and multi-turn agent workflows. One of the most powerful parts of agents is tooling. Agents can go beyond chat. They can discover and use tools from Foundry Catalog. You could get built-in tools like web search, file search, code interpreter, all fully integrated and out of the box. Agents can also use MCP tools, agent-to-agent tools, whether they are Microsoft hosted, partner provided, or custom, using a standard protocol. You don't need glue code. At runtime, the model decides when to call tools, turning these agents into systems that retrieve data and take real action. Right? Now let's look at some sample agents. So I've created a Foundry resource here using ai.azure.com. And in this Foundry resource, I have gone ahead and deployed a few models. I have GPT-5, GPT 4.1, and text embedding 3 small, and a bunch of other different types of models. I also have some agents already created. Now, to get started with code, I need 2 things. One is the project endpoint and the name of the model to use. I will be using these in a bunch of examples. Now I have several examples here, starting from the basic conversational agent, which does nothing, plain vanilla. I've added then function calling, then I've added file search, code interpreter, web search, MCP tools, and the last example is also I've combined multiple tools. So let's look at the first one. The first one, we create an agent called Travel Buddy with a model of my choice, and very simple. All it has is a prompt saying you're a travel buddy. You help users plan trips, etc. Keep your answers short, concise, and easy to grasp. And after that, I create the agent and I create a blank conversation, and I will use this conversation in every agent run. My first question to the agent is going to be, I have a week off in March, suggest 3 warm destinations. And I'm going to run a response based off of that and pass the conversation ID to the agent. It's going to give me an answer and add the answer to the conversation. So I will ask it a follow-up question, which will be, tell me more about the second option. What should I pack? And then I pass in the same conversation ID into this one as well and ask the response, and it's going to give me an answer based off of the context it already has. So a very simple agent which uses conversation to keep track of state. I've already run this. Let's look at what it says. So if you see, I asked it, I have a week off in March, so just 3 warm destinations, and the agent gives me 3 options: Cancun, Miami, and Tenerife. And I've asked, tell me more about the second option, and it gives me details about Miami. All right. Okay, that's the first one. Now let's look at the second one. In the second one, I have added a Python function for get weather, which is just fake data. It gives weather about 3 different cities. And I have then defined a JSON structured weather function tool for the agent to understand. And I now create an agent with instructions to use the weather tool, right? And I pass in the tool as a parameter when I create the agent. So I create the agent and then I will ask the agent what will be the weather in Cancun. And when I ask this question, the agent will use the tool, and based on the answers the tool provides, it's going to give me an answer saying that on March 15th, Cancun will be sunny, temperature 85, etc., etc. Next, let's make this agent a little more interesting. We'll add file search to it. So I created this product catalog MD file and have 3 separate plans for my travel company: an explorer plan, adventurer plan, and globetrotter plan. Now I upload this file into a vector store, right? And in your vector store, you'll obviously have several more files, but for this sample, we'll just use one file. And then I'm going to create another travel buddy. And instructions are, you use the file search tool to answer questions about plans and products. And always cite which plan you're referring to. And then I ask the question, what plans include travel insurance? How much they cost? And you see, I passed in the tool to the agent creation. So based on the tool I provided, it's going to give me an answer, and I will then ask a follow-up question which says, compare the adventurer and globetrotter plans for me. Let's see what the agent says. In this case, when I ask which plan includes travel insurance, it tells me that globetrotter plan has the travel insurance and this is the cost. And when I ask it to compare adventurer and globetrotter, here's what it tells me. It gives me the answer. Very simple. Now the next one is code interpreter. I've just created a code interpreter, and I've told my travel buddy that, hey, use this code interpreter to perform calculations, generate chart, and analyze data. So I've already created this. I've run the code to just create this, but I have not actually created responses using this agent. Let's create responses using the UI because it's going to be more fun that way. So my first question is going to be, I'm comparing. Let's copy paste this and ask the agent. So if I go back to the Foundry to the build tab, I have this travel buddy, and I've ran it several times. So there are several versions created. If you look at the top, you have all the versions. Now I know that version 4 is the one which I created with code interpreter. Version 5, for example, version 3 is the one with file search, which we just ran previously. Version 4 is the one with code interpreter. Now I'm going to ask the first question here. Let's paste the question and click enter. So I'm comparing flights to 3 destinations: Cancun, Bali, Maldives, and I've asked it to create a comparison table. And it did. Right? Now the next thing I'm going to do is I'm going to ask it to generate a bar chart comparing the total costs. Let's do that. And click enter. And there it is writing code to the code interpreter asking for a bar chart, and it created the image file for it. Let's click and download. There it is. Let me open this file, and here is the bar chart. Very interesting. Few lines of code, and the agent was able to do so many things for me. Great. Now let's go back and see what's our next sample. Our next sample, similarly, I'm not going to go through each sample here. Our next sample is web search. I'm just going to run web search. I've added web search as a tool, and I've told the travel buddy search the web for latest advisories and give me back info, and I pass this in as the tool. When I use a code like this and run it, here's what I'm going to say. What are the current travel advisories? The agent gives me this summary, right? And it also gives me all the sources from where it got this info. It gives me the citations as well, right? That's about web search. Then the next thing I'm doing is MCP tools. In MCP tools, I've created this MCP tool for GitHub. I use Git MCP, and I've said give me an approval, and I will ask it. I will pass this tool back into the agent creation and say use the MCP tool to look up documentation and assist the user. And my question is going to be summarize the Azure REST API specifications for me. Next, I also have code which gets back the response and checks if the agent is asking me for an approval request. And if it's an approval request, I send back an approval so that it can give me an answer. Now, when I run this piece of code, I've asked it to summarize REST API specifications, and here is the answer it gives me from Git MCP. So this can be an MCP server which you don't own, which anybody has owned, and you can just plug into it without having to write any code, just by defining the server and asking the agent a question. Now, last one is interesting for me. I've created several functions. I've created a book flight function. I've created a get weather function, and these are my custom functions which I have written. I'm also using a code interpreter tool and web search tool. Now I'll create an agent and tell the agent to use the weather, get weather for checking weather, book flight for booking flights, code interpreter for calculations, and web search for real-time info. And based on this, I will ask it a bunch of questions. What's the weather like in Bali today? What's the best search the web for best time to visit Bali, calculate flight costs, book me a flight, and all these things. Now, when I run all this, if you look at it, this is very cool. What's the weather? It asked the tool, get weather, and gave me an answer. Best, search the web. It searched the web and gave me back an answer. It also gave me citations from the web for that answer. Then if I asked it to calculate flights, it used code interpreter and gave me the total cost. And lastly, I've asked book me a flight. It used the book flight tool and gave me back an answer. So one agent uses several tools and is able to orchestrate all the tools by itself without the user having to write a lot of code. So what next can you do? There are so many more tools to try. AI search, Bing grounding, SharePoint, and so on and so forth. Try out all those tools. You can try many more advanced patterns. You can try streaming, structured output, multi-agent workflows, async operations. You can use telemetry, play around with the private tool catalog, etc. And I've also put a lot of reference links here, right? So this is what you can do. The last thing we're going to talk about today is the difference between the old and new agents. Some of the key changes are in the new agents, you no longer have threads. We now have conversations. Conversations support not just streams of, not just messages, but they support streams of several types of items. And then the next one is runs are now responses. We don't do runs anymore. We do responses. And of course, the last big change is the assistants or the older agents have now become newer agents. Newer agents are based off of responses API and not based off of assistants API. So based off all these are the three conceptual changes. This page also has a lot of code-based differences. Here is how you create a thread. Here's how you create a conversation. Here's how the output of a thread looks. Here's how the output of conversation looks. Here's how you add more items to a conversation. And execution. Here's how you create a run. Here's how you create a response. See how easier it is to create a response as compared to a run. Here's the output of a run. Here's the output of a response, right? And then here's how you create the older agent, and here's how you create the newer agent. And here's how the outputs will look for the old and the new one. And same way, we have a migration tool which is available on GitHub, which will help you move your existing agents into the new agent format. Now, one thing to make sure is this doesn't migrate the state data like past runs, threads, or messages. After migration, you can run the new code and any new state data is created in the updated format. But don't worry, any output which was created by your existing agents like files and other assets, they don't go anywhere. It's just that the state data is not saved. I hope all this information was useful for you. Thank you for watching this. Bye.
Thank you so much, Bala. And I've seen there's lots of interest in the chat about the demos. People are asking, about the GitHub links. The good thing is everything is publicly available on GitHub. So here you can see the QR code and the link, aka.ms/Microsoft-Foundry-Agents-demo, where you can find all the code samples that Bala showcased in these hands-on demos. So thank you so much, Bala, for joining us today.
Thank you. And I apologize for my voice sounding so congested in the demo. I was still not 100% when I did the demo, but so pardon me if I faltered and sound horrible. We would love to answer questions on an AMA on Friday. We're out of time today, so please feel free to look at the GitHub links, and that has all the demos I showed you today.
Right. The other good news is that we're going to have Bala again with us on Friday on the Foundry Discord server. So make sure to join the Foundry community if you are not there already, and see you on Friday for an AMA with Bala, so you can ask any follow-up questions about all the things he shared with us today. Huge thanks again, Bala. Thank you. Great. So I think we have we are very close to the end. We have a few minutes left. So I wanted to quickly share with you the news highlights of the week about the Microsoft Foundry and Hugging Face latest and greatest of the past week. So let's watch it.
Hello, everyone. Welcome back to Weekly Highlights on Model Mondays. And I'm super excited to, talk about some of the new models that landed, as well as certain adjacent features and tools that we have launched. So let's get started. Of course, first I want to talk about Sonnet 4.6. We already had Anthropic in the first half of this episode, coming in and giving you a very detailed overview of both Sonnet and Opus models. So at this point, I think you would all be quite familiar, but just for completeness sake, I wanted to let you all know that we added Sonnet 4.6 last week for Microsoft Foundry, and it now ships with a 1 million token context window and up to 128K output, meaning you can analyze massive code bases, long financial models, or multi-document workflows without constant resets. It also introduces adaptive thinking and effort controls, where the model decides when deeper reasoning is needed, and teams can tune quality, latency, and cost trade-offs. So why this matters? You now get smarter outputs without paying a performance tax when you don't have to. Moving on. The next model we launched last week is Mistral Document AI. We already had the Mistral document, the previous version of the Document AI model in Foundry. Now we have upgraded to the latest version, which is the Document AI 2512. And you all know, like, as if you're already like you enterprises are drowning in documents, contracts, invoices, reports, and forms that sit in unstructured formats long after they are digitized. So traditional OCR extracts text, but it often misses the context, layout complexity, and multilingual nuance, leading to manual rework and costly errors. Mistral Document AI 2512, now available in Microsoft Foundry, changes that equation by combining high precision OCR, which is the OCR 2512, with intelligent document understanding, which comes from Mistral Small 2506. It doesn't just read documents, it understands them. Multi-column layouts, merged tables, handwritten annotations, and multilingual content are converted into structured, machine-readable outputs like JSON or Markdown, ready for downstream systems. The result is faster processing, higher accuracy, and scalable automation across industries such as financial services, healthcare, legal, and manufacturing, transforming document-heavy workflows into intelligent analytics-ready pipelines with enterprise-grade security and deployment. Moving on, I wanted to just highlight a customer story from Pantone. This story highlights how agentic AI and AI-ready data architectures help power creative and operational workflows. By engineering a purpose-built database using Azure Cosmos DB and agentic workflows, Pantone teams can automate tasks, drive consistency across massive visual assets, and accelerate ideation with AI agents that truly understand design semantics and human nuance. This is a great example of AI plus domain data enabling real business transformation, not just automation, but augmentation of expert workflows. Please go and read. You should try out Azure Cosmos DB, but you should also go and read this blog. I want to take a slight shift in my highlights and talk about, we've previously never talked about a lot about infrastructure, but this is an important announcement. Microsoft has unveiled Maya 200, a next generation AI inference accelerator designed to fundamentally improve the economics and performance of large scale AI workloads. And built on TSMC's advanced 3 nanometer process, Maya 200 features native floating point 8 and floating point 4 tensor cores, a redesigned high bandwidth memory system, and keeping massive models highly utilized and minimizing data bottlenecks. This results in industry-leading inference performance and exceeding Google's latest TPU generation of processors. So with seamless Azure integration and a new Maya SDK supporting PyTorch, Triton, and low-level optimization, Maya 200 gives developers both portability and deep performance control, ushering in a new era of cost-efficient, high-throughput AI inference at hyperscale. And again, I wanted to highlight this because it's not just the large language models that are important, like the evolution on that, but we also need the hardware to kind of compete at the same level to give you the best performance. And that's what I wanted to point out, that at Microsoft we are tackling it on both sides of that AI journey. Moving on, the final highlight is the high AI generated is around media integrity and authenticity. And of course, as AI generated images, videos, and audio become indistinguishable from reality, verifying what's real online is becoming harder than ever. The media integrity and authentication technologies such as provenance standards from C2PA, watermarks, and fingerprinting are emerging as critical tools to help people determine whether content is authentic or AI generated. And with synthetic media surging, new legislation taking effect in 2026, and growing concerns about adversarial attacks, ensuring trustworthy governance signal is now a global priority. And Microsoft's latest media integrity and authentication report evaluates the real world limits, risks, and future directions of these systems. Go ahead and read more in this blog. Finally, I just want to take 30 seconds to talk about all the latest Hugging Face models that are coming to our platform. We have new ML, like if you're working with medical or biomedical text, the new ML's PubMed BERT-based embeddings is a strong purpose-built choice. It is fine-tuned on PubMed title abstract pairs, so it captures clinical and research meaning better than general embedding models. Then we have sentence transformers. So when you need multilingual semantic similarity without heavy compete, and it supports 50 plus languages and generates compact 384 dimensional embedding. So it's fast enough for high throughput systems and small enough for edge scenarios. And finally, we have BAAI BGEM3. It's interesting because it combines 3 retrieval styles in one model: dense semantic vectors, sparse keyboard style signals, and multi-vector matching for fine-grained relevance. And that brings us to the end of Model Monday's highlights. Thank you all.
And thank you, Sharmila, for these news highlights section. Interesting as always, and we are really living exciting time with this incredible pace of innovation every week. And thank you so much to everyone who is still live with us. I know we run a bit out of time, so I just want to wrap up with some announcements you might be interested about. So next week, Nitya from my team, you know her for sure if you joined other episodes of Model Mondays. She's going to host another great episode we're featuring as a partner spotlight Stephen Butterful from Black Forest Labs. And then we are going to have also our usual tech section with as a guest Sebastian Kohlmeier, principal PM at Core AI in Microsoft. And I have a few QR codes here, handy QR codes here, so you can rewatch past episodes available on demand of the show and look for the upcoming ones. You can join the Discord community, where again we host the Discord AMAs on the Friday, and we are going to have the upcoming one this Friday with Bala, same time as the show. And here's also a handy QR code to the GitHub repo, where we host all the material of the shows, including the hands-on demos you have seen today about the Microsoft Foundry Agent Service. So thank you so much again for joining us today, and see you soon to a Friday AMA and the next episodes of Model Mondays. Thank you.
Thank you all for joining, and thanks again to our speakers. This session is part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.